Okay, thanks for the introduction. So this is work done together with my colleagues Patrick Reipschläger and Ricardo Langner, as well as my supervisor Raimund Dachselt at the Interactive Media Lab Dresden. So as you might know, 3D visualizations have several challenges, such as misleading perspective or occlusion. You can see this in the terribly drawn 3D bar chart that I created in Excel there. Or also interaction, just imagine having to select a data item in the 3D scatter plot down there. So these are well-known issues, but we believe that mixed reality today has the potential to address some of these issues. And why is that? Now, we believe that mixed reality being suitable for 3D content can address these issues, for example, interaction. So we have non-traditional devices, new exciting interaction paradigms, spatial interaction, and so on. We also sometimes have situated data and a semantic connection even to a physical location. So this is an interesting trend. There's things like, for example, immersive analytics. Some of you might have known, might have heard about that. So a recent trend in visualization community. So one might be thinking about a revival, so to speak, of 3D visualizations. I wouldn't go that far because I don't believe that we can address all the issues, but at least try and look at what can be done here. And as I said, interaction is one of those things that might benefit 3D visualization. Spatial interaction might actually be one of the key advantages of mixed reality solutions. Compared to more traditional forms of input. When I think about that, or when we talk about that, we specifically mean, in this case, with like tablets or other handheld devices, that the device position is mapped to a virtual camera. And you basically, as you can see in the short video clip there, freely move around, explore visualization. In this case, it's virtually located on top of that table. And use that to basically explore the data. And you can also see a picture to the left of that. So this is what we're interested in. But the question is, of course, is this really useful? It might sound exciting, but maybe it's unusable or even worse than traditional input. So we don't know that yet. How do we use spatial interaction in comparison to other modalities? What are the benefits, if any? And of course, what could be possible limitations? And yeah, that's what we would like to find out. So what we did is a study where we compared spatial interaction to touch input for 3D data visualization on mobile devices. We, during that study, identified some interaction patterns that we believe are exciting, and we'll talk about that. And I believe we are able to form about some insights into challenges of situated 3D visualizations. So of course, we're not the first to look into this or to work in that area. There's a whole body of work concerning, for example, peephole windows. So basically, windows into 2D or even 3D information spaces, such as work done by Fitzmaurice or Spindler's work into tangible views for data exploration. Then there's, of course, several papers that use a mobile device, a tablet, or a smartphone as kind of a 3D controller for controlling 3D visualizations, kind of decoupling the input and output space a little bit. Then, obviously, mobile AR in itself and recent technological advances lead to new applications in that area, and we see the first visualization applications using mobile AR technologies. And then there are also specific studies on spatial input, such as the work up there, Benjamin Bach et al. Presented that some weeks ago at IEEE Viz. Also, Martin Spindler's work on pinch drag flick, where basically he he tested or he studied spatial interaction for 2D navigation or navigation in 2D datasets compared to touch, and found that this can actually outperform touch. So how does this work for 3D? Our prototype or setup for our study looks like this. So we have a tracked tablet. We have a virtual information space that we place on a table. That table is not interactive. It's just a kind of a physical landmark to orient yourself. And we have some study PC and so on. As the baseline condition of touch, we use a orbit camera model. You can see that in this video. So basically you use 1 or 2 finger drag gestures, and we support camera panning, rotation, and zoom. So it's basically the same prototype that we also use for the spatial interaction, but with a touch camera. Now, we investigated 3 different visualizations in 3 tasks. And the first is a navigation task. We have a 3D height map, and the task was to locate and select several markers, several targets in this visualization. So this was really heavy on navigation, and we tried to focus on that first. And then we had two more tasks that also obviously have navigational components, but also a little bit more than that. So the second task was a comparison task. For this task, we used a 3D bar chart, and as you can see, the task was basically to compare the height of 2 indicated bars and find out which one was higher. And the third one, we call that structural understanding task. So basically, you had a 3D scatter plot, and in this scatter plot, there were several clusters of data, and users had to explore the scatter plot and try to understand and memorize this, and then on an additional study PC, they were presented with several pictures of scatter plots. One of them was the correct one, and the others were similar but a little bit different, and they had to find the right one, basically. So as for our study design, we did this within subject design with the 3 tasks I just presented, and the 2 conditions of touch input and spatial input. We collected lots of data, obviously. We recorded all the participants during the study. We wrote down observations. And we also, and that's going to be important later on, tracked and recorded the camera position, both for the touch and for the spatial camera. In case of the spatial interaction, this was, of course, also the device position. We also had questionnaires. So after each task, we had Likert scale questionnaires on task load and user preferences. And we also measured task completion times and error rates where applicable. So in the case of the navigation task, there were no errors like that. So we had 18 students and postdocs taking part in our study. And all of them completed the study successfully. So let's see, what do we find out? Let's take a look at the results. Maybe let's start with the task load and the user preferences. So in general, and I have to say that I only present some of the results here, there's lots more in the paper. In general, we found out, and this is not surprising, that physical demand was higher for the spatial interaction task, because you have much more physical movement of the tablet in comparison to just holding it and touching. So this was not really surprising. But we also had better control of the camera. So users reported that they felt more in control. And overall, spatial interaction was preferred by most of the users. We also have some significant results specifically for the first task, the navigation task. So their spatial interaction was rated to be more precise, and users also reported a lower mental demand as well as stress level during the task. And they also had a higher perceived success rate. Some of the comments we got, and as I said, there's lots more in the paper. They said that spatial interaction was more memorable than touch, more engaging, also more intuitive. But they noted the weight of the device as one of the problems, and also tracking was sometimes criticized, so we had some slight jitter at the edges of our tracking volume sometimes. So those users that really made use of the whole interaction volume sometimes experienced that. Now, if you look at task completion times and error rates, it's interesting whether the preferred method of interaction also performed better. So as I said, perceived level of success was higher. And we also found that for the navigation task when looking at the data. So spatial interaction was significantly faster with quite a large effect size. But on the other hand, we did not find any significant differences between touch and spatial interaction for both the comparison task and the structural understanding task. And our idea here, our reasoning is that we believe that navigational components, that is basically what we do when we move the tablet around, don't play as big of a role in the more complicated tasks where you also had to focus on, for example, comparing to bars in this bar chart, and you didn't really need to navigate that much, or at least it didn't help you very much. Now, what's also interesting is that we observed several distinct patterns of interaction during the tasks, and this was kind of helpful because we found some exciting insights, I guess. So what we did is we observed those patterns during the study, and then we analyzed our video recordings and tried to come up with a list of those patterns. And then we validated that by looking at the tracked and recorded camera data. So we recreated a custom 3D camera trajectory plot visualization, and I don't know if you can see that in the video because it's rather fine lines, but you can see it maybe in the picture up there or also in the screenshot. Basically, what you can see there is this colored lines showing where the camera was moved during the task, and the color encodes the speed, or the relative speed, I should say, of the device. So red was slow movement or being stationary, while green is faster movement. And I'm also going to talk about some of the results we have here, but again, only the most important ones. So one pattern that we identified was, we call it bird's eye views. And I hope you can see it in the video, but try to explain as well. And you can see it on the left side for touch, and then again for spatial in the middle. Basically, the idea that users try to look at the data from above, trying to reduce the dimensionality. So if you look at a 3D height map from above, you don't have any occlusion, so this is helpful. And this is behavior that we didn't train them, we didn't tell them to do that. So users, and I have to say almost all of them, learned that during the task in a very short amount of time, and it was easier for them to look at that. And of course, for spatial interaction, you can't really hover above the data, like physically impossible, but still a similar pattern emerged. And the second one I wanted to briefly talk about is using the principal directions, for example, for the bar chart, but also in the scatterplot task. Users would look at the data from the sides, from the top, and from the front, and you can see those clusters basically in the camera movement data, and this is the same for spatial interaction as well. So let me briefly talk about some of the limitations of our study. Each task, and you might have noticed already, we only tested with one visualization, so this is definitely a problem. And our touch camera, while we try to do it as best as we can, there is no accepted gold standard, so you could argue that maybe a different touch camera would perform better. All the data, or most of the data we use is artificial, and our participants weren't really visual analytics experts, but yeah, students basically. So we don't know if this transfers to other user groups. However, we still found strong indication that navigation at least can benefit from spatial interaction. And navigation is kind of the basis for all other tasks, so this is kind of a good result for us here. Now, some insights that we found is that it's important to talk about the connection of the physical and virtual, so this should be done in future work, like the position and scale of the data, how to use physical landmarks, and we found the table was really helpful for our users, but this should be investigated further. Guidance and learnability is an issue. So this default strategies that some of our users used, could you try and tell them before that, build this into the visualization maybe in some way? So this should be looked into. And also tool assistance, because we had really simple tasks, and more complex tasks might need tools such as clipping planes and so on. So this is also some future work, I guess. So in conclusion, we believe that mixed reality might benefit 3D visualization. Spatial interaction is one, but not the only, of course, promising paradigm in this area. The results of our study, I think, we believe underline the potential. And we also found some distinct behaviors or patterns. Yeah, with that, I can only say thank you. My name is Wolfgang Büschel. Thank you for your attention, and I'm open to questions.
So we have some time for questions.
I'm Leila from Waterloo. So you mentioned that the users reported that with the spatial interaction they felt more in control of the data. Is that true? I was wondering if you know why that is. Did they feel like more immersed using that technique?
That's an excellent question. So the more or less exact wording of the question was, do you feel in control of the camera? And then, of course, they had to rate that on a Likert scale. So I wouldn't go as far as saying, as you said, feeling in control of the data, but rather the camera to explore the data. So I don't want to speculate whether or not that's because of immersion. I believe it was mainly being a very intuitive interaction technique. It was really fast. So, for example, we had, of course, some short training period before the tasks, and we found that this is basically not needed for spatial interaction. So for touch, they needed a little bit of training to understand all the capabilities, like do you need one finger, 2 fingers, whatever. For spatial interaction, it was instant, basically. So that might be a factor.
Hi, thank you very much. Very nice work. Miguel Nacenta from University of St. Andrews. Have you thought about hybrids? I think kind of like you navigate in using the interaction, but also the space itself. So
The hybrids? Sorry?
Hybrid techniques.
Oh, so you mean combining spatial interaction and touch, or? Yes. So we didn't really test this in our study, but I believe, or we believe, I should say, that this is one of the advantages, and it's also one of the reasons why we looked into mobile devices instead of AR glasses or something else. The advantage of having both the option to use spatial interaction, but also touch, for example, for precise movements, for selection, obviously. So we didn't look into this in this study, but this is one of the things that I believe are very promising. For example, also using spatial interaction to position the camera to navigate, and then using touch to control a clipping plane. And this is something that we tried out in our prototype, but didn't do in the study. Thank you.
Yeah, I agree with you. I think it's an interesting direction for future work. Thank you.
Okay, let's thank Wolfgang again.